Welcome to excelmasterseries.com. Today we're going to show how to use all three types of built-in ANOVA in Excel to improve your pay-per-click marketing campaigns. Now ANOVA stands for Analysis of Variance, and it's typically used to determine whether three or more variations of one factor or treatment have the same effect on a population. And ANOVA tests the null hypothesis for each factor, and the null hypothesis for each factor states that varying that factor has no effect on the outcome. And the end result of ANOVA is to either accept or reject the null hypothesis. And if you reject the null hypothesis, it doesn't automatically mean that you accept the alternate hypothesis, which states that varying the factor did have an effect. And you need to determine up front the degree of certainty that you're going to require for your ANOVA test. For example, you might wish to require a 95% degree of certainty of whether or not to accept or reject the null hypothesis. And alpha is derived from that degree of certainty. Alpha equals 1 minus the degree of certainty. For example, if you required a 95% degree of certainty, then alpha would equal 0.05. The ANOVA test generates a p-value. And as a general rule, if that p-value is greater than alpha, then you accept the null hypothesis, which states that varying the factor did not have an effect on the outcome. If the p-value is less than alpha, then you reject the null hypothesis and you state that within a degree of certainty that you required, varying that factor did have an effect on the outcome. There are three different types of ANOVA in Excel: single factor ANOVA, two factor ANOVA without replication, and two factor ANOVA with replication. Let's take a look at each one. Single factor ANOVA just tests the effect of one factor. Everything else is held constant. That one factor has its own null hypothesis stating that varying that factor did not have an effect. Two-factor ANOVA without replication. You're just adding one more factor in there. Everything else is constant. Each of those factors has its own null hypothesis test. And the final type is two-factor ANOVA with replication. So you're keeping the two-factor test and you're replicating it in two different places so that you can test the interaction between the two factors. So each of the two factors will have its own null hypothesis, and the interaction also will have its own null hypothesis, stating that varying that interaction did not have an effect on the outcome. So let's take a look at the first test we're going to run. We're going to run single factor ANOVA to determine whether varying the headlines affects the click-through rate of an AdWords ad campaign. And what we do, we create 5 different sets of ad text. Each set of ad text was run with 3 different headlines under identical conditions until 1 million ad impressions were reached for each combination. And the resulting click-through rates for each of the 15 different ad text headline combinations is shown right there. So we want to determine within 95% degree of certainty whether or not varying the headline affected the click-through rate. So this is how you have to record this information for this test. So we know that our degree of certainty is 95%, so alpha is 0.05. And there's one null hypothesis for the headline stating that varying that headline did not have an effect on click-through rate. Let's run the test. So we hit Data, Tools Data Analysis, then ANOVA Single Factor, hit OK. Then the input range. We're going to put that in right now, and everything in yellow. That's why you have to put the data in just like that. So everything in yellow is highlighted for the input range. And the labels are in the first row, as we can see. Data is grouped by columns. And alpha is 0.5. And the output range, that would be the upper left-hand corner of where the output's going to start. So hit OK and run that ANOVA analysis. So there it is. And I'm going to color code that. And we can see that the source of variation between groups, that's for the headlines. Basically, how do you interpret that is there is only a 0.001% chance that there would be that much variation between the headlines. So we can see that that p-value is quite a bit less than alpha. So in this case, we reject the null hypothesis. So let's do our second test right here. And we're using two-factor ANOVA without replication to determine whether varying the headlines and or the ad text affects the click-through rate. We run exactly the same test. 5 different sets of ad text. Each set of ad text is run with 3 different headlines under identical conditions. So 1 million ad impressions were reached. The resulting click-through rates of those 15 different ad text headline combinations are shown. So determine within 95% degree of certainty whether varying the headline or the ad text affected the click-through rate. And this is how the information needs to be recorded right there. We know that our degree of certainty is 95%, so alpha is 0.05. And there are 2 null hypotheses, one for the headlines and one for the ad text, stating that varying each one of those factors did not have an effect. So let's go run this test right now. And remember, this is Excel 2003. So we hit Tools, Data Analysis, ANOVA two-factor without replication. And the input range, everything in yellow, just like that. That's the only difference between this and the previous test. Okay, and Labels are in the first row. We're going to select the output range, just the upper left-hand corner or wherever we want the output to start. Okay, hit OK, run that ANOVA, and there's the output. I'm going to color code it. And this time there are two different p-values. One for the add text, that's in yellow for rows, and blue for columns. We see the add text for rows, the p-value is 0.6, and that's greater than the alpha. So we would say that the add text did not affect the outcome, but the p-value for columns is 0.005. That's for headlines. So we would say that within that 95% degree of certainty, varying headline did have an effect because its p-value was quite a bit less than alpha. So now our third test, we're going to use two-factor ANOVA with replication to test whether varying the headlines or the ad text or the interaction between the headlines and ad text will affect the click-through rate. Same test. The only difference is we're replicating in two places, not only on Google but also on Yahoo. So same test. Create 5 different sets of ad text, and each ad text is run 3 different headlines under identical conditions. 1 million ad impressions were reached, and the resulting click-through rates for each of the 15 different ad text headline combinations are shown for both Google and Yahoo. So that's how you have to record the information for this kind of a test, just like it's done here. So determine within 95% degree of certainty whether varying the headline, ad text, or the interaction between the two affected the click-through rate. That's what this test determines. So we know that our degree of certainty required is 95%, therefore alpha equals 0.05. And now there are 3 different null hypotheses. One for the headline, and one for the ad text, coming up here in a second. And finally, one for the interaction between the headline and the ad text. So three different null hypotheses. So let's go ahead and run this test. And this is, once again, Excel 2003. It's at Tools, Data Analysis. So that'll be ANOVA two-factor with replication. Hit OK. And the input range, everything highlighted in yellow, just like we've done here. That's why you've got to put the information in like that. Let's go back to the dialog box. And there are 2 rows per sample because we're running the test in Google and also in Yahoo. So 2 per sample, and the alpha is 0.05. Output range, we're going to select the upper left-hand corner where the output's going to start. Right there. Okay, and run the analysis. There's the output. And I'm going to color code it so we can read it a little bit easier. And this time we have 3 different things we're testing. Sample, which is ad text in yellow. We can see the p-value for sample is 0.15, and that's greater than alpha, so we accept the null hypothesis for that one. For the headlines, that's in blue, the columns, that p-value is 1.8 to the 10 to the negative 6. That's a lot less than the alpha of 0.5, so we reject the null hypothesis in this case, stating that headlines, varying the headline did have an effect on the outcome. And the interaction, that p-value is 0.04, and that's less than alpha of 0.5. So we reject the null hypothesis in this case for interaction with a 95% certainty, and we say with 95% certainty that varying the interaction between ad text and headline did affect everything. So if you'd like to be an Excel statistical master, check out the Excel. Check out www.excelmasterseries.com, and you can download this graphic manual for free. It's 100 pages of how to graph in Excel. Okay, thank you very much, and goodbye.